All right, so here's our intro. So Pizza Hut invented the stuffed crust pizza back in 1995, so probably, definitely before you all were born. Now recently they started offering the nothing but stuffed crust, which is a pizza that actually has no pizza, only the crust. So we're going to be thinking about a series of questions here about measuring the crust. So that's going to be just this outer piece. And then we'll be looking at another set of questions where we're going to be thinking about measuring the pizza on the inside, which is going to be this first picture over here to the left. So let's look at question 1. So it says that a large pizza has a radius of 7 inches. So if we were to make a visual picture of this, we have a circle here to represent the large pizza size, and we know the radius measure is halfway across our circle. So I'm just going to label that here so we can see that's our radius of 7 inches. The question is, how many inches long is the crust for the entire pizza? So we are wanting to measure the crust distance, kind of like the perimeter, measure around the outside. Now back in geometry, when we learned about different measurements of circles, this was called the circumference. And we have a really nice formula for getting the circumference of a circle. It's based on the radius, which we have the radius. So we will be able to figure out our circumference. So our circumference formula is 2 times pi times r, where r represents the radius of our circle. So if we were to plug in our radius of 7 inches, so I'm going to display this here with a graphing calculator, but you should also be able to find a pi symbol on your scientific calculator. I'll actually give you a couple of ways that you can do this. On mine, I'm going to type it in the exact same way that I wrote it here on paper. So I'm going to write 2, and then I'm going to press my second key on the graphing calculator. It's the pi symbol is on top of the exponent key raised up to the power of. There's a little blue pi symbol above that key that's pressed down in red. And then I can actually just type 7, or I can write multiplied by 7, and we can see that it's about 43.98 inches. Now, another way that you can do this is you can use the approximation for pi, which is it's about 3.14. So you can type in 2 times 3.14 times 7, and it's not exactly the same as what we had, but it is very, very close. The more decimal digits of pi we have in as an approximation, the closer, more accurate our answer will be. So let's bring that number back here on paper. I'm going to go ahead and use the first one. So that's going to be about 43.98 inches. All right, it says Ms. Gallus cuts a slice of pizza that makes an angle of 62 degrees. We're going to find out what fraction of the whole circle is this angle. So let's think of this as a fraction. So we're going to put the 62 degrees here on the numerator. How many degrees do we have in a whole circle? 360. So that is going to go on our denominator. So the question is, all right, out of 360 degrees total, what fraction is the 62-degree angle that represents the slice of pizza that she cut? So initially, this is our fraction. It's 62 out of 360. Now I could try to reduce this a little bit. I'm noticing that both the top and bottom are even numbers, so I can divide them both by 2. And that's as far as we can go. That 31 is prime. We're not going to be able to divide that by anything else other than 1. So I'm going to keep my answer here as 31 over 180. All right, so in part 3, we're going to look at how long is the crust for this slice of pizza. Well, we know the fraction of the pizza that the slice represents is 31 out of 180. And we can now multiply that by the length of the entire crust, 43.98. And let's jump back over here to our calculator and talk about a couple of ways that we can do that. So you could do 31 divided by 180, and get that as a decimal, and then take that decimal and multiply it by 43.98. And this final answer here, that 7.57, that's going to be the length of the crust for that individual slice of pizza. Now, another option here on our calculator is we can type this in all at once. So the way to separate it is to put the fraction part around parentheses, put parentheses around it, use the division sign to represent that it's a fraction, and then multiply by the 43.98 at the end. The calculator can do all the pieces at once, and we still get the same result here at 7.57. All right, so now here in part 4, we're going to try to generalize this process that we just did. We're going to write a formula for the crust length of a pizza that has a radius of r and a slice that is measured with the angle theta. So if we think about what we did here in part 2 and 3, 62 degrees was representing our angle theta. So to generalize it, I'm just going to use a theta symbol to represent any angle. And what we did is we divided that by 360 degrees. That's what we did in number 2. And then we took that answer and we multiplied it by 43.98. Well, 43.98 was the circumference of the circle. Generally, the circumference is 2 times pi times the radius. That is our formula. Now, I'm actually going to put an equal sign here in front. And if we were to give a name to this formula, what we have calculated, the length of the crust for one slice of pizza is actually what we call the arc length for that slice. So I'm actually going to put another big box around this. That's a general formula that we can use to get the crust length for any slice of pizza with any central angle measure on the inside. Now, let's also be clear that this particular version of the formula is when that angle theta is measured in degrees. We're going to continue now into the second half, and we're going to talk about measuring the pizza. So we're going to be thinking about the total area of a large pizza, and then eventually what's the area for just a particular slice of pizza. So remember, back in geometry, we had a formula for the area of the circle. It also involved pi. It also involved the radius. But instead of 2 times pi times r, it was pi times the radius squared. Or in other words, radius times pi is equal to the area. So let's go ahead and do this again. For our large pizza, we know that it has a radius of 7. So we're going to do pi times 7 squared. And if I go to my calculator here with the pi symbol, I can do that again, multiply that by 7 squared. I could type it in like this, 49 times pi. I could use the approximation, 49 times 3.14159. We'll get a few more decimals there to see if we can get a bit more accurate. Notice how all of these are giving us an area of about 153.94. And the units here are now inches squared. 153. This is measuring the area of the inside part of our circle. All right, now Mr. Wilcox cuts a slice of pizza that makes an angle of 74 degrees. We're going to see what fraction of the whole circle is this angle. All right, so we have a central angle measured in degrees. Let's do the same thing again. Let's do 74 degrees divided by 360. These are both even numbers again, so if we divide the top and bottom by 2, we end up getting 37 over 180. All right, so that's going to help us get the area of this slice of pizza. So this slice of pizza represents 37 over 180. That's the fraction out of the entire pizza. Let's go ahead and multiply that by the area of the entire pizza. And again, in our calculator, we can do this a couple of different ways. You could do 37 divided by 180 and turn that into a decimal, and then multiply it by 153.94, or you can type it in all as one piece. Either way, we should get about 31.64 inches squared for this particular slice of pizza. All right, so in part 8, we're going to generalize this now again. So we're going to look at the steps for what we did in number 6 and number 7. We're going to write a formula for the area of a pizza with radius r, and it has a slice of angle theta. So the first thing that we did up in part 6 is we did our angle theta in degrees. We divided it by 360. So that was our first step, is we had to figure out what fraction of the whole pizza does this represent. And then we just multiplied that by the area. The formula for our area was pi r squared. Now, the way that we're going to label this one is we're going to call it the area of a sector. So the slice of pizza part, this part, is actually called the sector of the circle. Now again, this is when our angle is measured in degrees. All right, so what I'd like you to do here before we turn over to the back is think about this challenge question at the bottom. What would be the formula for the crust length? That was the one that we did first up here. In other words, arc length. And the area of the sector, if our angle theta was measured in radians instead of degrees. So I want you to think about how you would make some adjustments to those two formulas and write down the radians version down below at the bottom. Yeah, so the part of the formula that is specific to degrees is the 360 degrees. I'm going to highlight this here for both parts. Everything else about our formula here will stay the same. So starting with the arc length formula, that's going to be this one. Now we're going to have our angle theta in radians divided by 2 pi. 2 pi radians is equivalent to 360 degrees. Now let's think about this, because notice how that's still being multiplied by 2 pi r. Well, that's really like 2 pi r over 1. Now, when you're multiplying a fraction by another fraction, if you happen to have a common factor on the numerator that's the same as what you have on the denominator, it can be from different fractions. Because if you think about this, when you multiply across the top and multiply across the bottom, it's just one big numerator and one big denominator. Look at this. The 2 pi on the top is actually going to cancel with the 2 pi on the bottom. So in radians, it simplifies down to be a much simpler formula for arc length. I'm just going to make a note here that when our angle is in radians, all we have to do is do that radian measure, multiply that by the radius, that's giving us our arc length. Okay, let's see what happens here for the area of the sector formula. So here we have theta divided by 2 pi radians. Now that's being multiplied by pi r squared, which is really pi r squared over 1. We do have something that we can cancel here. We're not canceling 2 pi on the top and bottom, but we can cancel the pi on the top and the bottom. So a simpler version of our area of the sector formula, when our angle is in radians, is we do our angle multiplied by r squared divided by 2. And again, that's when our angle theta is in radians. All right, so our first learning target here for today was to be able to calculate the arc length of a sector when given an angle and a radius. And then the second one was to be able to calculate the area of a sector when given the angle and the radius. We saw that we can deal with these angles in degrees like we did with the pizza problem. We could also do it if our angle was in radius. So for our quick notes here, let's just make a note, a reminder. Our formula for the circumference of a circle, circumference measures the perimeter. It's the line around the outside of our circle. It would be like the total length of the crust, is equal to 2 pi r. R represents the radius. And then the formula for the area of our circle, that's measuring how many like little square units we have on the inside of our pizza. That's pi times the radius squared. Now, both processes that we did today can be broken down into 3 very simple steps. Step 1 is to calculate circumference or area of the whole circle. Step 2 is to find what fraction of the circle the sector is. And when we say sector, we mean an actual slice of pizza. So the sector looks something like this, pizza slice. Now, in degrees, we saw that we need to do our angle theta divided by 360. If it was in radians, we're doing our angle theta divided by 2 pi radians. All right, step 3. We multiplied them together. So we multiplied the fraction that we just found in step 2 by the circumference or area of the whole circle to find the information that we're wanting for the sector. So to either find the crust length, the arc length of the sector, multiplied by circumference, or if we want to find the area, the size, inside size of the sector, then we would multiply by the area.